letting them. Yay.
Okay.
Right.
All right, great. So Fred already covered my background some, but I'll talk a little bit about my background with entomology. My love for insects started as a really little girl. My mom talks about me chasing ants as soon as I could walk. My first memories with insects was I had a baby doll stroller, so I was probably, I don't know, 6. And instead of pushing around my doll, I pushed around a stroller full of crickets and caterpillars. And the crickets were a little difficult to keep in. And then when I was about 8, I discovered aquatic insects, and my mom had to survive years of me using every Tupperware container on the front porch full of aquatic insects. So I knew from a young age that I wanted to go to school for entomology. I started at Penn State with my bachelor's. Penn State doesn't offer an entomology major, so I minored in entomology and studied just general agricultural sciences. And then I stayed at Penn State to get my master's in entomology. I had 2 projects that I worked on. We'll talk a little bit about each of them today. One was more on field crop entomology and looking at slug and ground beetle populations in corn and soybean fields. And then I also did some work with neonicotinoid insecticides and their transport from crop fields into water. So after school, I worked as a crop scout in eastern Pennsylvania and New Jersey, scouting crop fields for insects, diseases, weeds. And I was also a nutrient management planner, helping farms that produce lots of manure stay in compliance with their manure regulations. So I came to Penn State about 3 years ago and started as a master gardener coordinator and spotted lanternfly coordinator. I was in that position for about 6 months before moving into agronomy, which is really where my background is. I also now serve on our new and beginning farmer team, helping to connect new farmers with the resources that they need to get started. Outside of work, my husband and I also farm a little over 200 acres in Chester County, Pennsylvania.
200 acres. Seriously?
Yeah, I
Wow.
mean, he
Sorry
does
for
the
interrupting. That's quite an endeavor. My goodness.
yeah, he does the majority of the work, and I help when I can.
Wow.
But
What
that's
corn
sorry,
and soy?
mostly corn, soybeans, wheat, a lot of hay. Chester County, we have a lot of horse farms and a lot of needs for hay, so
Wow,
it's
that's
fun.
fabulous. Yeah, it
Mhm.
is.
Yep. So we'll start with the take-home messages for today. So we're going to talk about building predator diversity to improve pest control by combining no-till and cover crops and integrated pest management. From research that we've done at Penn State and research from other universities, we know that increasing diversity can improve crop production. And we're going to talk about using cover crops and how we really need to pair that with integrated pest management if we're going to use cover crops for pest control. So to start, we'll cover some of these terms like integrated pest management, no-till, and cover crops before we dig into some data. So this group, I probably don't need to spend a ton of time on integrated pest management. But integrated pest management, we want to use a combination of tactics to control our pests. Generally, chemical control is going to be our last option. The chemical control is part of integrated pest management. So there's tactics like biological control, cultural control, changing the environment to make it maybe less favorable for our pests. There's chemical control tactics, mechanical or physical control tactics, genetic, regulatory. There are many different ways that we can prevent pest populations and then manage them if they show up. So integrated pest management was introduced by entomologists in 1959 to protect our natural enemy populations. They're our allies in our crop systems, and also to ensure profitability. we don't want to be using insecticides if they're not needed, because that's going to hurt our bottom line. So our key principles are that we want to avoid preventative insecticides. We only want to treat for insect pest populations that we know that we have and that we know have exceeded our economic threshold. And so it's very important with IPM that we are scouting to know exactly what's in our fields and when that insect may or may not be a problem. So no-till practice is planting our crops without using tillage. In Pennsylvania, we estimate that about 75% of our soybean fields and about 65% of our corn fields are in no-till production. Some benefits of no-till, you have decrease in labor needs because you're not out there with tillage equipment. Also because you're not out with tillage equipment, you're going to conserve fuel. No-till is also going to conserve our soil because you're not disturbing the soil. It's going to build better structure. It's more likely to stay in place. And because we've built that good soil structure, we're also going to conserve water because that good soil structure is going to be able to retain more water. And because we're creating this more stable environment, we're also going to provide more habitat and habitat stability for natural enemies. And ideally with no-till, we want to prevent this from happening. So here we had a big rainstorm, and you can see all of this surface water running off of the field. And you can see all of the soil leaving the field in that surface water. So this field was likely tilled, so that soil was disturbed and is more easily available to run off. So we want to keep our soil in the field. So when we look at cover crops, anyone not familiar with field cropping systems, cover crops are something that we're going to plant between our cash crops. And the goal is to keep a living plant with living roots in the soil on the field for as long as possible throughout the year. Often cover crops are going to be killed or terminated before the cash crop is planted. Sometimes this cover crop can be harvested. Some farmers will even graze the cover crop to extend the grazing season for their livestock. So some of the benefits of cover crops, just like no-till, we're going to conserve our soil because we're keeping living roots in the soil, holding it in place. And because we have that good soil structure, we're going to improve the amount of water that we're able to retain in the field. Having those living roots are really important for soil health and soil quality. And having that living plant, we're going to improve nutrient management. So any nutrients or manure that get applied to that field, having that living cover there, that plant is going to take up those nutrients, keep them in the field, prevent some of them from running off in water or leaching through the soil. With cover crops, we also have improved pest management. Part of this is, when we pair cover crops with no-till, we have that really stable or more stable environment to have a more complex food web. So we're going to have more predators to help with our pest control. And then cover crops can also help with weed control by providing a physical barrier for weeds that might be emerging. One thing to note with insect and slug control, if we have cover crops, it's going to depend on the year. There are some cases where cover crops can actually cause some pest issues. So in corn, we do have a few corn pests that we commonly see, or will more commonly see in no-till fields that have cover crops. These are the black cutworm. Let me grab my laser pointer. So we have black cutworm here, white grub, true armyworm, and slugs. So all four of these are sporadic pests, very common in the spring, early summer, when the plants are small and vulnerable. Some So for these, Bt hybrids and preventative insecticides provide variable control. And the most effective management approach is to scout for these pests in the spring and treat when appropriate. Because these are sporadic, sometimes it's hard to predict what year they're going to be an issue. So the black cutworm here, as its name implies, it's going to cut the plant. So here you can see a young corn seedling lying on its side. These often come out to feed at night. So you'll go to bed one night, you have a beautiful cornfield, you'll come out the next morning and you'll start to see plants cut. And sometimes they'll drag these cut plants back to their little burrow. And then true armyworm, they are going to feed on the margins of the leaf down to the center midrib of the corn leaf. And like the black cutworm, these are also going to feed nocturnally. And then during the day, they hide in the whorl of the plant. So generally these are an issue when when the corn plant's about this big. And if you start to see their feeding, if you look straight down into the plant during the day, you'll often see a little caterpillar staring back at you. So both of these caterpillars, neither of them overwinter in Pennsylvania. The moths arrive on storm fronts in the spring and early summer. And for some reason, the moths tend to be attracted to fields with heavier cover. So in white grubs, they're underground pests. They're going to feed on the roots of the corn and weaken the plant that way. And then slugs, I know they're not insects, but I spent a lot of time working with slugs during my master's. They're going to feed on a very wide range of plants. In Pennsylvania, we are most concerned in field crops about the marsh slug, which is pictured here, and the gray garden slug, which I'll show a picture of on the next slide. So they're going to scrape the surface of the leaves. In corn, they're going to create long streaks of damage down the leaf. You can see here, this one's feeding on soybeans and it's hitting the cotyledon of the soybean. So this year in Pennsylvania and in Maryland, we had a very bad slug year. So in soybeans, I talked about sometimes cover crops can increase pest damage. So in soybeans, we tend to see slugs. Can sometimes be more of an issue in cover crop fields, but not always. And we'll look at cases where cover crops can actually help at the end of this presentation. So slugs are also sporadic early season pests. We see them every spring, but most springs we don't see them in large enough numbers to cause bad damage. Corn and soybeans can generally outgrow slug damage as long as the slugs don't kill the plant. And by late June, early July, the summer is hot enough that the slugs go deeper into the soil for the rest of the summer and we don't see them again till the fall. So these two here are the marsh slug, and then this is our gray garden slug. The gray garden slug, full grown, is about twice the size of the marsh slug. So with slugs, it's really important to encourage our natural enemy populations. They're really going to help us. So while we're on slugs, I do have a slug fun fact to throw in here. So every spring, the agronomy educators throughout the state put out square foot shingle pieces in soybean fields, and we check those shingles throughout the spring to track slug populations and look at nearby damage to try to alert growers if they need to be on the lookout for slugs. And I was checking traps this spring, and I turned over a trap and I saw this. And it was a fun reminder that slugs are hermaphrodites. They have male and female parts, and their reproductive organs, reproductive tract is near their head. So when they lay eggs, they're laid out of an opening near their head. And this is not something that I've never seen in person. I was very excited. I spent about half an hour watching the slug lay eggs. And I was lucky enough to get a photo or a video. I'll share that here. And there comes the egg. So just a
Yep.
quick diversion. Oh, what was that?
Have you ever seen them mating?
I've never seen the marsh or the gray garden. I've seen leopard slugs, and they hang from kind of a mucus
Yeah,
rope.
a real long
Yeah.
strand of mucus, and they twirl around and they tangle themselves up. It's unbelievable.
Yeah. Yeah. So I
Um,
think the gray garden slug, it's either the gray garden slug or the marsh slug, they don't use that mucus rope. They create kind of like a mat of mucus on the ground.
okay.
Um,
I never
yeah,
saw one laying eggs before. That was pretty cool. I had no idea how that. I wouldn't have guessed it comes right from the side of their head, though. That's pretty
yeah, so
crazy.
logically, I knew that their reproductive tract was there, but I never thought about egg laying. And this was the first time I had seen it in person, and mind blowing. Very
Yeah,
interesting.
yeah.
Yeah. Okay, I can move away from slugs for a few slides now. So now that we've had a little introduction to our field crop system, no-till, cover crops, IPM, the rest of the presentation I'm going to break out into two sections. So this first section is the larger section. We're going to talk about the importance of using IPM for field crop pests, um, mostly as it relates to overuse of pesticides. And then we're going to go through how we can use cover crops to help manage these pests. So I just wanted to pull back those key principles from the beginning for integrated pest management. We want to avoid preventative insecticides as much as possible so that we can protect our natural enemies. And by not using preventative insecticides, we need to make sure that we're out scouting fields to know what pests are there and if they've reached any economic threshold for it to make financial sense to treat for them. So if we protect them and provide habitat, beneficial insects and spiders can establish pretty well in crop fields. These are all photos I've taken over the past few years of these predators in action in corn and soybean fields. So we have our lady beetle laying eggs on a corn leaf. We have the spider eating a little caterpillar on the soybean leaf. Here we have our spined soldier bug consuming what I believe is an alfalfa caterpillar. We have a little jumping spider with an orthopteran in its mouth, a wolf spider walking across leaves carrying her egg sac. This one's a little more disguised, but there's a praying mantis here consuming a grasshopper, and then a ground beetle eating a white grub. And I love to include videos when possible. So this video came out of my advisor's lab, John Tooker at Penn State. So here we have a wheel bug nymph and a silver spotted skipper caterpillar sitting on a soybean leaf. And little does the caterpillar know that it is being hunted. You see the wheel bug nymph take out the caterpillar. So silver spotted skippers are occasional pests of soybeans. I see them in every soybean field I go into. I've never seen them cause enough damage to treat for them. They're very cool. If anyone has any experience with silver spotted skippers, they will chew a flap along the edge of the leaf and fold it over and attach it to the leaf with a little bit of silk, and then they hide in that little flap. And as they get bigger, the flap gets larger and larger. So ground beetles, especially as it relates to slugs, are very important predators in field crops. Both the adults and the larvae are predaceous. There are many species of ground beetles that we find in crop fields. In Pennsylvania, this is a Pterosticus species. They're very, very common. And coincidentally, they feed on a lot of the pests that we see in fields that are no-tilled and cover cropped. So these are really important predators to try to conserve in those systems. And then here is a video I got, I think 2 years ago, of a different species of ground beetle eating a white grub. So we do recognize that insecticides are really valuable tools when they're used correctly. So there are different ways that we can use insecticides. We can have foliar applications like the sprayer here. We could have soil applications in corn and soybeans. Many planters now have a tank or a box to put an insecticide in so that you can apply the insecticide right in furrow as you're planting the seed. And then we also have seed treatments. So these are applied directly to the seed before planting. So you can see this picture of corn. In the middle here, you have untreated corn. It just looks like yellow corn. And then you have blue seed here and red seed here that has been treated with either an insecticide or a fungicide or both. So we always advocate that the best framework for applying pesticides is with integrated pest management, making sure that you're scouting for economically damaging populations. We also need to recognize that if insecticides or any pesticide really are used blindly, they can have unintended consequences. In particular, they can decrease the beneficial insects in fields, leaving those fields more vulnerable to pest populations. And then indiscriminate use of insecticides can also cause environmental concerns like water pollution. And we'll talk some about water pollution in regards to one insecticide that I worked with in grad school. So overall, we see that insecticide use is increasing. So this first figure is showing the use of the insecticide bifenthrin from 1992 to 2017. And then it's organized by crop. So red, or not red, yellow and green here are indicating corn and soybeans. So you can see a pretty significant increase of bifenthrin use just in those two crops. And then we look at the neonicotinoids. These are commonly used as seed treatments applied directly to the corn and soybean seed. And here we're looking at use from 95 to 2014, 2015. And again, we see that steep increase, especially in corn, which is red, and soybeans, this dark yellow orange color. It's interesting to note, though, that overall, the complex of pests that we're dealing with has not changed a whole lot over this time period. We've had a few new pests increased, but they haven't turned out to be significant pests of field crops. So more often than not, these days, corn and soybean seeds are coated with a neonicotinoid seed treatment. And this is a really common way that we see an overuse of insecticides in field crops. They're very often just used as an insurance preventative treatment. And so we're going to focus more on the neonicotinoid seed treatments for this presentation, also because we have a lot of research coming out of Penn State on these seed treatments. So they do have some benefits. They can protect yield if that insect pest is present and in yield limiting numbers. However, this only happens about 5% of the time that we see a yield benefit to the seed treatment. Another benefit is that these are water soluble. So we can coat a small amount on the seed. Once that seed starts to germinate, that insecticide ends up in the soil water, gets taken up by the roots, and becomes systemic in the plant. This systemic activity is going to persist for about 40 days and will protect the whole plant, but this activity does begin to wane after about 2 to 3 weeks. So after 2 to 3 weeks, we tend to lose a lot of effective activity against pests. So because they are water soluble and have the systemic activity, it's nice that we can apply a targeted low dose just where they are needed, which is going to be better than a broadcast foliar application. They're also good because they are very toxic to insects and generally have a lower mammalian toxicity. So it would appear that this directed application would provide little chance for exposure to beneficial insects, such as pollinators and predators. Unfortunately, we are learning more and more that this is not the case, and there is some impact on beneficial populations. So here is some insight into the influence of seed coatings on yield for corn and soybeans. These are data from our research farm in central Pennsylvania and are very typical of what we're finding making this comparison from year to year. So these are the data from 2016 and 2017. So on the left, we have soybean yield on the y-axis, and on the x, we have our untreated control, and then soybeans grown with the neonic seed treatment. And we see there's no significant difference in the yield. When we look at corn the following year, again, there is no significant yield difference between the treated and untreated seed. Both of these years, we did have low pest pressures, so we wouldn't have expected to see a difference to begin with. So looking to provide further insight on the benefits and value of seed coatings, there was a large study published in 2020 by entomologists from the University of Guelph in Ontario, Canada. This group studied hundreds of corn and soybean fields in southwestern Ontario, which is adjacent to Michigan, and has an ag landscape and climate that's somewhat similar to Pennsylvania. So at hundreds of farms, this group made replicated comparisons of corn and/or soybean growth with a fungicide seed coating and compared that to a fungicide plus a neonic seed coating. So from their results, they found the great majority of fields saw no benefits from using the insecticide, the neonic seed coating, and only about 5% of fields showed a benefit from the insecticide. So the majority of time that these are used, we're not seeing a yield benefit. So this is a closer look at some of their data specifically for corn early in the season. So we're looking at 4 variables. We're looking at the stand counts, the amount of plants per acre, right as the corn is emerging. So that's this VE-V1 growth stage, is when the corn's about this big. We're looking at below ground injury from insect pests and above ground injury from pests, and then comparing the yield. So we have N, our number of farms or number of fields. FST stands for the seeds coated with just the fungicide, and NST is going to stand for the fields that had the fungicide and the insecticide on the seed. We see there's no significant difference between the two treatments, meaning that having that neonicotinoid insecticide on the seed didn't provide any benefit for these 4 variables. And then when we look at some of the pests that they were studying, again, we don't see any difference between the 2 treatments for both wireworms and white grubs. So occasionally you will see a benefit, but once averaged out over many fields and many years, they do not provide much value. So we'll get into some research done at Penn State now. So this was a study done at the Penn State Research Farm in central PA. It's where a lot of our neonic research is done. And we wanted to know, do the neonicotinoids or neonics exacerbate slug populations in the field? So this was a soybean trial. We had 6 soybean plots in red that the seeds were treated with thimethoxam, that's one of the neonicotinoid insecticides, and a fungicide. And then the gray fields were left with untreated seed. So first, this group confirmed that slugs can indeed decrease soybean yield. So here on the left, our y-axis is the yield of soybeans compared to the number of soybean plants in the field. And you'll see once we have more soybean plants, we have greater yield. When we look at these data points, the open circles are the control, so these are the untreated seeds, and the solid points are the neonicotinoid treated seeds. So you'll see these plots tended to have lower yield and fewer soybean plants. And when we look at slugs in these fields, we're now going to look at the number of soybean plants per acre and how that relates to slugs per trap. And these are those shingle traps that I was talking about earlier in the presentation. And we see as we get more slugs, we end up with fewer soybean plants. And again, we see a trend with the control versus the treated plots, where the treated plots look like they appear to have more slugs. So then this group counted slug predators and looked at predation in the fields. So on the y-axis, we have predation. This was determined using sentinel prey monitoring. For this, we took a little piece of clay and pinned a waxworm to the clay. This was put inside of an exclusion cage to keep out vertebrates and birds so that only insects and spiders could get in. And then we go out late afternoon, early evening, and twice overnight to look at the predation of the waxworms. So this predation, the proportion of waxworms killed, was compared to the number of slug predators that were found in pitfall traps nearby. And we see a trend that as predation increases, we also find more slug predators. And again, when we look at the data points, we see that the insecticide treated seed tended to have lower predation and fewer slug predators. So now we look at the actual slugs that we're finding per trap, and we compare that to predation. And we see that as predation increases, we see fewer slugs in those fields. So from this, we can conclude that insecticides seem to be disrupting biological control of slugs. So having that neonicotinoid insecticide seed treatment seems to be decreasing our predator populations. And we see that here in another study, also from the same farm. We're looking at a comparison of, again, treated red and untreated seed. This time we're looking at a cornfield. Here's a photo of a pretty severely damaged corn seedling from slugs. And so you can see on average over the growing season, we're looking at slugs per trap and then the dates of the growing season. Overall, we tended to find more slugs in plots that had the insecticide seed coating. And this is, we think, because we're seeing fewer slug predators in those fields. Now, slugs are mollusks, so when they feed on the treated plants or the treated seeds, they are going to ingest that insecticide without it affecting them. But now they are going to become toxic to their predators. And we have a great video illustrating this. So first, we will see, this is a ground beetle called Clanius tricolor. So first we'll see a normal beetle. These beetles are very fast. They move around a lot. Now this beetle ate a slug that had consumed a treated plant, and now it's not doing so well. So this project took place back in 2015, also in John Tooker's lab. And they found that ground beetles can actually be poisoned by the slugs that have fed on these corn or soybean seedlings that had treated seed. So in this study, they're counting the number of beetles that are either dead, impaired, or normal after feeding on slugs that fed on these treated seedlings. So in our untreated control, all of the beetles were acting normal. In the treatment where there was only a fungicide on the seed, again, all of the beetles acted normal. Once we had a low dose of insecticide or high dose of insecticide coated on the seed, after the beetle fed on the slug, over 60% of the beetles were either impaired or dead. And when they took this project to the field, they saw that seed treatments depressed arthropod predators, reducing the soybean population, so the number of soybean plants in the field, by 19% and decreased the yield by 5%. So, can IPM for pest control work? This is an ongoing example from a long-term project at Penn State. This is the Penn State's Diversified Dairy Cropping Systems project, which aims to test the viability of longer rotations, or crop rotations, for a small to medium-sized dairy in the state. This project has been going on for over a decade now. I spent part of my master's work on this project. I think I came in around maybe year 8 or 9. And this project has been testing two types of no-till crop rotations. So a crop rotation is simply, I'm going to plant this crop next year. I'm going to follow it with that crop next year. So the first rotation was a very simple 2-year rotation of corn and soybeans with no cover crops planted between those two cash crops. And then we had 2 diversified rotations. These were 6-year rotations, and they had corn, soybeans, alfalfa, small grains. They also incorporated cover crops. From an insect management perspective for these 2 approaches, our simplified rotation, we're using a preventative insect management approach. So we're using BT corn. This is Bacillus thuringiensis. It's a trait in the corn that targets specific insects, generally beetles or caterpillars. And then we're also using seed treatments and then a broadcast pyrethroid following planting. And all of these are preventative, not based on scouting applications. So we call this rotation our high input approach. For the longer, more complex rotation, we're going to use integrated pest management. So we're not going to use BT corn traits. We did not use seed treatments. We were scouting the plots every week to track pest populations and then only using an insecticide if we had an economically significant outbreak. I think during my time at the project, we had 1 or 2 plots that had true armyworm damage that needed to be sprayed. So this we refer to as our low input rotation. So as we've been tracking pest populations in these plots, we found some interesting patterns. Notably, our pest populations for both insects and slugs have been most abundant in the simpler high input rotations where we are using preventative insect management. And we believe that the reason for this difference in pest populations between these 2 types of rotations is going to lie with our predator populations. So these figures show the predator populations in the first 6 years of the project. So our vertical axis are going to be the slug predators per pitfall trap per day. And then on the x-axis, we have year 1, year 2, 3, 4, 5, 6. We have our high input. So that's our 2-year rotation with preventative pest management. And then our low input, which is going to be our diversified rotation using integrated pest management. So we see in the first 3 years of the project, the natural enemy populations were significantly equal between the 2 rotations. But in year 4, you can see the slug predator population in the low input longer rotation is higher than in our simplified high input rotation. And this pattern continues then for years 5 and 6, and we've seen that continue throughout the life of the project. So we see that it does take time if you're converting to this type of system. It does take time to see the benefits of those predator populations. So if we look at the data from the first 6 years all combined into this figure, we're going to look at slug damage on the y-axis. So this is the proportion of plants with slug damage, and compare that to predators found per trap. We do see a decrease in slug damage as our predator populations increase. So this is exactly what we want to see from this predator population that we've been trying to protect in our low input IPM rotation. So bottom line, we advocate to our farmers to try IPM, even if it's only on a few acres to start until they get the feel for it, work out the kinks. In most cases, insecticides are generally not needed. So it's important to scout for problematic pest populations and then only treat if that's needed. Now, when I introduced the insecticide portion of today's talk, I mentioned briefly that one of the negative consequences of overusing insecticides would be environmental concerns. So we're going to continue to focus on the neonicotinoids just because of how widely they're used in crop production. So this is a schematic representation of the environmental fate and transport of neonicotinoids applied to crop seeds. So this study found that about 2 to 3% of the insecticide applied to the seed is actually taken up by the plant, and only about 5 to 8% of the time do they see an economic benefit to that application. Another 2 to 3% of that active ingredient is lost as dust at planting. So you can see that indicated by the purple. And then that leaves over 90% that's ending up in the water, in soil, non-crop plants. And that's, you're spending all this money for this product and it's going away. So we're going to focus on neonicotinoid transport in water. So because of how soluble these insecticides are, we do know that they move with water within fields. So this is a project that came out of Penn State again, looking at the total neonicotinoids in dry soil compared to how steep the slope was. So if we're looking at this photo, we have a steeper slope up here that's going to flatten out at the bottom. And this study found lower concentrations of the insecticide in the soil at a steeper slope compared to a less steep slope, indicating that we have transport from up the hill, down the hill in the soil. We also know that neonics move with water out of fields. So this is from my master's work. Based on previous studies, we know that neonics are leaving fields and getting into water. We wanted to try to quantify the percent of applied insecticide or applied active ingredient that is leaving the field in surface and subsurface flow. So the Penn State Research Farm in Central PA has great lysimeter plots set up. There are 12 plots on a hill. And so here the plot is indicated by this corn. So surface water is going to flow and hit this inlet grate. And there's a berm here to protect it from going into another plot. And then this pipe is going to take it to our collection house. Similarly, our subsurface flow is going to hit this gravel curtain and then go into a pipe and also go into the collection house. In the collection house, we have these tipping buckets that are hooked up to a data logger. So we know how many times they tip, we know the volume of each bucket, so then we can calculate how much flow we're getting. And then every time the bucket tips, a very small subsample of that tip ends up in a collection bottle. So I would go out and collect samples after every significant rain event. A significant rain event was just one that produced enough water that we could actually collect a sample. And then I would take these back to the lab and I would test them for both thimethoxam and clothianidin. So both of these are commonly used neonicotinoid seed treatments. So the seeds that we planted were treated with thimethoxam, but thimethoxam very quickly in the soil breaks down into clothianidin. So we tested for both throughout the growing season. So typically, let's introduce these figures first. So this top row, we're looking at the water flow over time. So this is May 26, 2017 through April 26th, 2018. So we're looking at the flow data, looking at our significant rainfall events. 2017 tended to be a little on the dry side. 2018 was very wet. And then here we're looking at thimethoxam load in the surface runoff and the subsurface flow, and then clothianidin again in the surface runoff and the subsurface flow. So as we expected, we saw a flush of thimethoxam early in the season around corn planting, and then it kind of tapered off throughout the rest of the season. And we saw this in both the surface flow and the subsurface flow. But then clothianidin seemed to persist much longer throughout the growing season. And remember, thimethoxam is going to break down into clothianidin. So this project was meant to go on for 2 years, and in year 2, someone on the research farm accidentally planted untreated seed. So I wasn't able to capture data for the second year, but we were able to track thimethoxam and clothianidin even the following year after the seed was planted. So during this study period, we accounted for about 1.09% of the insecticide that was applied to the field. 90% of that was in the subsurface flow, and about 10% of that was in the surface flow. And this delivery ratio is similar to those of other trace level emerging contaminants that are known to negatively influence aquatic systems, like streams, rivers, lakes. And so when we look at some data from watersheds in Iowa, we see that neonics are moving out of fields into streams and rivers. So here on the left, we are looking at how much of the cropland is planted in the area. So we have corn in yellow and green is soybeans. And we see that we're fully planted by the end of June. And then here at the right, we're looking at total neonicotinoid concentration in local streams and rivers over time. And right about the time that everything is planted, we see a spike in neonicotinoid concentrations getting into our streams and rivers. And this is concerning because we're still learning about what this is doing to our aquatic insects and our aquatic plants. So to wrap up, neonicotinoids, research has shown that in most cases, they do not provide a benefit to yield or profitability. And they can only protect the plant if the pest is actually present in a large enough population. So using integrated pest management can help reduce this insecticide's abundance in the environment. We will admit it can be difficult to purchase seed without this seed treatment, so we always recommend that farmers start to shop early for their seed to try to find untreated seed. So Fred, I see we're already at 8 o'clock. Would you like me to finish up or wrap up here?
You can finish up. I don't know how much more you got left, but
Um, maybe 6 slides.
I'll go ahead and finish. That's
Okay,
fine.
sounds good. So we'll talk briefly about using cover crops to manage pests in these systems. So no-till is going to serve as the base for conservation-based farming, trying to keep our soil in our fields, build very healthy soil, build that stable habitat for beneficial insects. But cover crops can really add to the conservation. So cover crops can build predator populations by giving them more habitat, more alternative food within that habitat. So to protect the value of that habitat, we need to use integrated pest management, scout our fields, deploy insecticides only when necessary. I know at this point I probably sound like a broken record, um, but we really try to get this point across with farmers that we're talking to. So most people assume that cover crops lead to greater pest populations, but if we combine them with scouting, we really can use them for pest control by preserving those predator populations. So this figure, we're looking at the relationship between white grub populations, so our pest in corn plots, and cover crop biomass from earlier in the growing season. So here, oops, there we go. So here on the y-axis, we're looking at white grub density, so how many white grubs we're seeing in a quarter meter plot. And then the horizontal, we're looking at the amount of biomass from the cover crops. So how thick that cover crop was. And we do see when we have more cover in the spring, we do have lower white grub density later in the summer. And then we also see what we attribute this to is that when we have greater biomass, so again, here on the x-axis, we have greater ground beetle density, so our predators. So one thought behind using cover crops is that they could provide an alternate food source for both our pests and our predators. So someone asked the question, can intercropping improve slug control? So here intercropping is planting a cover crop, so this rye, between the rows of soybeans. So the thought is that a clean field, so a field with just the soybeans, is only going to provide one food source. So if we add the second food source, we might be able to distract the slugs. And then once the soybeans are big enough and the slugs kind of go away for the summer, this cover crop, the rye, can be terminated with like Roundup. So this was an on-farm trial. We love when farmers let us do research on their farms. So here we're looking at slug damage rating on a 0 to 4 scale. So this is percent of the soybean plant eaten. So like a rating of 1 would be 25% of the plant is consumed by slugs. So a rating of 4 would be the plant is dead. And we're comparing that to no rye planted between the rows of soybeans and rye planted between the rows. And we did see lower slug damage when we had this intercropped rye. Similarly, when we looked at the number of ground beetles between these two treatments, we also saw more ground beetles where we had the cover crop. So something that's starting to gain some traction is called planting green. And if no one has heard of this, this is when you're planting your corn or soybeans into a living cover crop. Generally, when people use a cover crop, they're going to terminate it with a herbicide before planting. But here, they're going to plant directly into the green cover crop and then come back and kill it usually within a week of planting. So now you have this dying cover crop with a lot of biomass that's also going to provide a food source for slugs as the corn and soybeans are trying to come out of the ground. So with planting green, these farmers generally, they want to keep their soil covered as long as possible throughout the year to really protect it. They want to increase their organic matter. Through this, they're going to increase their biodiversity because they have more habitat and healthier soils. But with this system, you really need to commit to integrated pest management because you have to conserve those predators in the field. If you're going to plant green and use preventative insecticides, you might run into more issues because you've lost your beneficials. And then there are some fun ways to plant green. So this is planting into a crimson clover cover crop. Some people might do this because legumes can provide nitrogen to the following corn crop. I also think it's just beautiful. So
It
people who
is
are,
beautiful.
yeah, some people who are really committed to planting green can get specialized equipment. So here we're looking at a planter. So the planter, if it's in the ground, it would be moving towards us. So it has these discs in the front that form a V, and these are going to move any debris out of the way where the corn and soybean plant or seed is going to go into the ground. And then behind these discs, it has this roller, and this is going to push the cover crop to the ground and crimp it so that it stays down. And this will make it much easier then for the planter to drop seed in the ground. If someone doesn't have this type of planter, they can also get a roller for the front of the tractor, so they can roll it down and then they have the planter behind the tractor. And here you can see that rolling where they've pushed it to the ground. You can see the rows where that disc had pushed away the debris. That way you get good seed to soil contact. So some of the benefits of rolling, you get really uniform ground cover. You have better planting because you've pushed that cover crop to the side. And in this case, the biomass is going to persist through most of the growing season. You'll still see the dead cover crop there at the end of the year, conserving soil, providing habitat. And at this on-farm study, we did side by side with rolled rye, where we treated with Acre Max, that's a type of seed treatment, versus an untreated, untraded corn, and found zero difference or very little difference in yield of that corn. We'll quickly go through these. Again, we're looking at planting green and slug control. So this top figure, we're looking at the number of slugs per shingle in June, July, and August, and then comparing that to our cover crop treatment. So bare is no cover crop. Brown is a cover crop that's killed before planting. So it's brown and crispy by the time you're planting. And then green is you're planting green and then killing the cover crop later. And we see in June, we have our significance up here. We had significantly fewer slugs in the planted green plot in both June and in August. When we look at all of this data together, we're looking again at the average number of slugs, the cover crop treatment, so bare, brown, and green, compared to treated and non-treated. we see, again, significantly fewer slugs in that planted green system, but only if we were using non-treated seed. So we were protecting our natural enemies. And now when we look at predicted yield, based on the cover crop treatment, we do see a slight decrease in yield in this study. So there are some trade-offs that can happen, but it really depends on the producer's philosophy for farming. If they run the numbers, their savings on insecticide and seed treatments might make up for this slight loss in yield. Again, it's really important to keep the soil covered. So this is that planted green plot at the end of the season that was rolled. You can still see that cover crop conserving the soil compared to no cover crop. And with that, we have our take-home messages from the beginning. Really, we just want to build predator diversity as much as possible in cropping systems. But to do that, we need to protect them by avoiding unnecessary pesticide use. So again, thank you for inviting me. I always love to have time to talk about insects.
All right, thanks. Can you go back to your last slide?
Yeah,
And then maybe folks can ask questions too. If you show your last slide, your take-home message again.
oops. I think I shared the wrong screen.
What happened? One back.
Okay.
There we go. Okay. Um, does anybody want to ask any questions? Please, now's the time. Go ahead and unmute yourself and ask.
Fred, I've got a few questions. Let me ask
Sure.
Sarah. One thing I was interested in knowing, and I don't know how much you're involved with herbicides or not,
Mhm.
but I was the watershed manager for the city of Baltimore.
Okay.
And our rural water supplies, I was responsible for them. And when I first started, and this was like 40 years ago, we had a lot of problem with sedimentation, with sediments coming into the reservoirs. And what happened, a lot of it was from construction, but a lot of it was also from row crops. And construction, they got under control with regulations, but farm crops, it was always BMPs were suggested, but they weren't required. So then something new came along where no-till was put in. But with no-till, and this is where my question is,
Mhm.
the cover crops, they were using herbicides then to kill the cover crops. And my recollection was atrazine, simazine, and the concern was, well, is this getting into the water? And as it turned out, it was getting into
Mhm.
groundwater and surface waters. So is that still used, these herbicides for cover crops?
Yeah, so atrazine and simazine are used to prevent plants from germinating and emerging. So they are still used, um, but they're usually used in combination with other herbicides that are going to kill actively growing cover crops. There are limits on how much atrazine you can use in a year to try to limit the amount that's getting into groundwater. I don't know all of the regulations off the top of my head.
Okay. My other question was, it seems like seed coatings with neonics seem to be kind of a pervasive use. And it seems like your data that you're showing says don't use them,
Hmm.
you know, and you'll have a higher yield and it'll be less expensive. And
Yeah.
I don't know. I don't know. Is the word not getting out about this?
It is. So you run into a lot of feelings with farmers because they see it as an insurance treatment.
Mhm.
And there's that fear that, oh, what if I don't use it and then I get an outbreak? So there's that. And then you combine that with a lot of industry automatically coats seeds. And so it can be difficult for a farmer that maybe wants to try an untreated seed to find that seed, especially in a variety that they would like to plant.
Mhm.
Um, so you're dealing with fear and an industry saying you need this. Um, so my advisor, John Tucker, spends a lot of time trying to convince people to try without the treatment.
Okay. And one last question.
Okay.
With the planting of rye between corn crops, or between corn rows, I should say,
Okay.
I don't see that as a problem. Between soybeans, then I wonder, with people with celiac disease and gluten, uh, if any of that rye gets harvested along with the soybeans.
No, so that intercropping, that rye is going to be terminated likely with Roundup before it would ever mature. So generally, once the soybeans are big enough to fend for themselves against slugs, the grower would come in and spray the rye to kill it.
Okay. Yeah, I was concerned about field contamination
No, that's a fair
from
question.
the rye.
Yeah. Hmm.
Okay, that's my questions.
Great. Thank you.
I was going to ask one of the same things too, because I live in a rural area and they use a huge amount of herbicide every spring.
Hmm.
In some areas, and I'm sure it's up there the same, you can drive for miles and just see brown fields everywhere where they've
Yep.
sprayed the herbicide.
Yeah,
Um,
that's.
how much of that gets into people's wells?
Oh, I don't know the answer to that. We have a water team at Penn
Guess
State
people
that
have
would
to
know.
test their water.
Yeah.
Yeah.
Um, and again, farmers should be following the label. Um, and the label will offer directions on trying to avoid well contamination. Um, yeah, and it's one of those things with no-till. It's great because you're conserving your soil, improving soil health, but on the flip side, you don't have tillage to control weeds now. So it's one of those trade-offs that now we have to use more herbicide to control weeds.
It seems unfortunate, and I'm concerned about it because I have well water and there's a big
Mhm.
farm in front of my house, and they use plenty of sprays over there.
Yeah, my house
Um,
is the same setup.
mhm. Do you drink your well water?
We do. We have a pretty good filter.
Use a filter in it? Okay.
Yeah.
And what's that? Is that a point source like a carbon filter at the kitchen sink or something?
We have a reverse osmosis for our drinking water. Um,
Oh, you go that far with it, eh?
yeah, it was already installed when we bought the house.
Right, right.
Yeah.
Well, we drink bottled water
Okay.
mostly, because of these concerns. So I was just wondering about that because our
Yeah.
well is kind of shallow too. Our well's barely 100 feet,
Okay.
and that's shallow for a well.
Hmm.
And I know that stuff gets in there, these chemicals get in there. So um, I'm going to start having it tested more regularly, but certainly during the planting season when they're spraying the herbicides a lot, then we don't drink much of the well water. But other than that, once that is over and a little time goes by, I drink it. I don't think there's going to be any worries once they've stopped using it. But I just wondered, is this something that can persist? And even though they stop using for a couple months, let's say, will that will the chemicals still be in the water? Do you know?
Yeah. So I'm not an expert on herbicides, but it's going to depend on the ingredient, and how it interacts with water, how water soluble it is, if it binds to sediment. So it's really going to depend on the ingredient.
Okay, fair enough. Yeah. Something else I wanted to ask, I can't remember what it was now. It's back when you're going through your slides and anyway, it's okay. But
You can email me.
yeah, right. Thank you.
Yeah, thank you.
Anybody else have some questions they might want to ask? I wish more people more farmers would adhere to some of these. As Gene said, I mean, isn't the word out there yet for this?
We're trying.
Yeah.
Usually January through March, for my work, I'm in pesticide meetings for certified applicators that need continuing education
Mhm.
credits. So I'm teaching pesticide education courses, and I usually try to sprinkle a little bit of this in every year.
Good.
Sometimes it's taken well, sometimes it's not. Depends on
How
them.
about in Maryland? Do you know anything about what's going on down here with that?
Not really. No.
Okay. I'm
Um,
sure the University of Maryland probably has all kinds of information on it. So
mhm.
anyway, all right. Well, uh, anyone else have something they want to say?
Not a
Okay. Well,
question, just a comment. You showed a slide of water running off of a field and bringing soil across the road. And
Yeah.
it reminded me, as a child, I grew up in Lancaster County, Pennsylvania.
Okay.
Little Conestoga Creek was near my house, and there were a lot of active farms still in the area at that time.
Hmm.
And as a child, I thought that by definition, creeks were brown.
Oh.
They had so much soil in them.
Oh my gosh. Yeah. Oh, that's really far back.
I can see that happening.
Yeah. Wow.
Yeah. Well, happens a lot, doesn't it? All right. Well, very good then. Sarah, I want to thank you for taking the time to meet with us tonight and give us a great presentation.
Thank you for inviting me.
I certainly learned a few good things here tonight that I was unaware of. So thank you for sharing all that great information. I certainly hope that in the future that we see more applications like this, across the board and people turning to this methodology. It seems to be a pretty good win-win kind of situation, I would say. So,
Yeah, it's more management, it's more time in the field. Um, this is where hiring a crop scout is very useful. Someone who's just there to look at your fields.
mhm. Do you go to the Penn State Insect Fair in September when they have it?
I I was in State College this year at the same time, but I was hosting a conference down the road and couldn't get away.
Oh, okay.
So,
I
but
asked because I've gone up there occasionally for that, and if so, is it something you would attend usually?
I try to if I'm in the area. It's been a few years. The first time I went, I was 8 years old, and that's when I learned what an entomologist was and was sold.
Good. Well, you got sold on it right away than when you were little, right?
Mhm. Yep,
A
I
lot
went
of us,
through.
yeah, a lot of us started out as kids. That I did too. I began chasing butterflies when I was in grade school, early grade school. So
Mhm.
it's something that stayed with me the rest of my life.
Yeah.
Anyway, I hope maybe we'll cross paths one day up there. Who knows? It's a small world.
Yeah,
But
that'd be great.
yeah, we hope we stay in touch somehow. And thank you once again. Appreciate it. You should be receiving from us if you have an address, by the way, that you want us to send the journal. I don't know if that was already that didn't get brought to your attention, did it?
Yeah, I
No.
I can send you an address.
Okay, good. So
Yeah.
then I'll forward that to Jean, and we'll send a journal to you. And
Thank you.
you're an honorary member of the Maryland NSOC now for a year, okay? And
Thank you.
you'll get
Okay.
our mailings and stuff. So anytime you want to join us, please feel free and welcome, okay?
Great, thank you. I saw there's was it a WASP diversity talk coming up?
Right, yes, that's coming up November. Yeah,
Remember with Eric Eaton.
yep.
That'd be good.
So yeah, join us anytime for whatever, and we have a variety of different talks. It's always something different, and um, sometimes it's stuff along your line of work. Other times it's completely different, So in any case, uh, thanks once again, and I'll see if our members will stay on for a quick business type of meeting, talk about whatever we need to, and we'll adjourn after that. But Sarah,
Right.
you're free to log out and um, shoot me an email when you get a chance with your preferred mailing address so we can
I'll
send.
contact Sarah over the
Okay,
Okay,
weekend
you will? Okay,
and get
that's
all the
great.
contact information from her and send out the journals to her.
great.
Okay, that
Thank you.
sounds good. Okay,
Have a good night.
thank you, Sarah. Bye.
Thanks. Bye.
Take care.